Hey, good evening. Welcome to Meteorology Lab. We're back for another week. And it doesn't look like very much out there right now, but there are big changes going on in Texas this evening. And we're going to be going over some of that shortly. And what you see out here, this is looking off towards the west, northwest, somewhere in there. And that's an anvil from storms near Brownwood, south of Abilene. Looking at about 130, 140 miles away, but they've already started overspreading our area here. All right, let's head into the maps and see what's going on across the country. Now, there's something we haven't seen in a while, giant area of high pressure covering all of the northwestern U.S. into the central and southwestern states, and you can see that this has reached all the way back to Arizona there. And we'll put up the plots there and see what's going on across the country. And you can see 30s and 40s across much of the country. And down in Texas, in Kansas, and Colorado, even snow being reported in some of those areas right there. So this is a Canadian front working its way southward, and it's going to push all the way down into the Gulf by tomorrow. And then we're going to have the second blast coming in from the west. Okay, let's take a closer look at the station plots. And here's what we're seeing in Texas, and it's pretty easy to pick up exactly where that front is. And we're going to go somewhere like that. And then once we get into the higher terrain and the mountainous areas of New Mexico, we tend to curve that back because the mountains act as a barrier. Even that, nevertheless, you can see there in Albuquerque, they're getting strong easterly winds. Typically, these strong Canadian fronts, they don't have that much of a westward reach. You'll typically see the west end of those fronts end up around Klein's Corner, Las Vegas, Raton, and not really get too much further west. So this definitely has some kick to it. Sometimes they'll even get canyon winds in that area right there with very strong outbreaks. And then we take a look up to the northeast, and there you can see the snow from Garden City and Dodge City all the way down to Perryton and back up towards Lamar, Lyman, and Eads. I don't know if there's any accumulation out there. I know we have a few people on the stream from the Denver area. Feel free to comment. And it looks like even more snow back around Colorado Springs, Lyman, and Pueblo. So we're definitely getting our first big taste of winter. And then we'll just take a look up in Canada, see if there's anything else on the way. Put up those temperatures, and not really. In fact, look at that. Isn't that weird? 59 up there in northwestern Alberta. Kind of big extreme there, you know, from the plains where you got 30s and snow, and then you go up here and you find warm weather. Even there in Fort Nelson, 66, almost up there in the Yukon. But they're getting some of that downslope flow coming in from the Pacific. So it looks like up to the north, not a whole lot of cold air in place up in that region. But we'll check out the GFS and see if that's likely to change. Okay, then the tropics, because it is October, so we have to kind of keep an eye on what's going on down there. Nothing going on really right now. Looks like we finally lost, I think that was Leslie out there in the Atlantic. Looks like a slight chance of cyclone formation there in the Caribbean. Let's look at the 5-day tropical outlook. I saw the GFOS was picking up on something out around Mexico that would recurve back into Texas at the end of next week. But that's kind of a ways off. So it looks like we got a slight chance of something forming around the coast of Honduras there. That's probably not going to affect the U.S. Going to SPC's products, this is the outlay of surface winds and pressure and the radar. And you can see a little bit of a indication of where the front is right there. The deeper convection, a little multi-cell storm there, southwest of Fort Worth there. And that's probably going to continue moving eastward, probably rolling across Waxahachie and Hillsborough and out towards Athens later this evening. All right, taking a look at the upper air. Here's the picture from this morning. We don't have the 0Z plots in yet. But it looks like we got a little bit of a split flow going on. Up to the north, there's the main branch of the polar front jet, forming a trough out there in Wyoming and Montana, and the rest of it heading up into the Great Lakes. And the southern branch showing down here. This could be a subtropical jet. We'll take a look, but for now, some sort of jet from the El Paso area down out to Oklahoma City and out towards West Virginia there. So to distinguish whether that's a subtropical jet, we just go down to 500 or 700, and we've still got energy in that band right there, so that's definitely a split flow polar front situation there. So two jets in place there, and those are going to be supporting that Canadian front coming southward. All right, going to the thickness and isobars. High pressure centered across Wyoming and Colorado there. That's pretty much the core of the cold polar air there. And then the leading edge of that front, pretty much like we saw there on the surface chart. And then the warm sector, the warm front sector, we've got to keep that in mind there. Looks like it's around Kentucky. You can see south of Kentucky out there in Tennessee, Alabama, Mississippi, not much of a thermal gradient, but you go up north and yeah, there's definitely a thermal gradient up in this area here. So we're going to put that warm front probably like that right there through Kentucky, dividing it between north and south. So let me just take a quick look at the surface data and see if I can resolve that with actual data. Yeah, it's kind of in the ballpark there. You can see those 70s out there around Huntsville. Probably still warm in the Nashville area, and then, yeah, that all aligns pretty well there. Okay, let's see. The next product, I think what we'll do is we'll take a look at a couple soundings. This is something kind of unusual that we're going to do. We're going to go from south to north, maybe from Lake Charles. Then we're going to look at the Dallas sounding, and then Oklahoma City, and then up into Dodge City, and then up to Denver, and then maybe up to Rapid City. So what we're doing is we're kind of taking a trip across the front back into the cold air, and let's see what it looks like. So Lake Charles, obviously that's going to be in the tropical air, so let's look at that air mass there. Lake Charles should be coming up here. Nope, don't have the 0Z data yet, so we're just going to take a look at this morning's data. So here's what Lake Charles looked like this morning there. Looks like a little bit of a loaded right in here. You can see the tropical air down below 900 millibars, so that's going to be about 2,000 or 3,000 feet thick. Above that, a bit of a cap right there. And there's dry air within that capping region. And then above that, looks like a moderately steep lapse right there. So if they had a little bit more moisture or more instability in the upper levels, we'd be looking at good chance of severe weather in that area. Okay, going up to Fort Worth, they're probably not going to have the frontal passage this morning, but we do see a little bit of a frontal boundary right in there. So I guess I did have some sort of frontal zone in that area. There might have been some old outflow from yesterday. But let's see, within that layer, looks like we got south winds. There's that frontal inversion, and then above that, looks like we pick up a little bit of a subsidence inversion up at about 700 millibars. Now, once we go up to Oklahoma City, we should start getting into some of the cold air. Okay, we see surface temperatures in the area around 11 Celsius, which is about 52 Fahrenheit. And the winds are still out of the south in that area. So this is probably an old polar air mass. And let's see, once we go up to Dodge City, we do pick up the north winds there. And the air mass is not only fairly cool, but it's actually very deep. This was a little bit surprising. See how that tops out right there? That's going to be up at about 8,000 to 9,000 feet. 8,000 or 9,000 feet thick at Dodge City. Well, if you go back to this map and 8,000 feet thick there, and then you go out to, say, Las Vegas, New Mexico, Santa Fe, Klein's Corner, that's all about 7,000 to 8,000 feet MSL. So if it's 9,000 feet, should have no problem clearing that. So this is actually a good situation for air masses to push west, that kind of depth. Okay, going up to Denver. So we're going to get deeper in that cold air mass, and wow, this is pretty impressive there. There's the top of the air mass right there. That's up at about probably 12,000 to 13,000 feet, so that's enough to clear some of the Rockies. Let me check back there. Okay, the Front Range is in this area, then we get into the Sangre de Cristos out in this area here, and it does look like we have easterly flow in some of the intermountain stations there, Alamosa and what's that other one? Salida. But yeah, that's a very impressive frontal inversion for Denver. And then let's go up to our final station, Rapid City. And there we pick up the top of the cold air mass up at about 11,000 feet. You can see the strong northerly flow through that region. Now, here's another way of looking at things. You're probably wondering why all this cloud material and snow is back in this area. So we're going to take a look at isentropic analysis. This is a tool we use in the cold season to look at airflow, which air does not necessarily move just horizontally. You know, if you read textbooks, you might get that impression. Air does tend to move vertically, not only in thunderstorms and showers, but it tends to move ascend air masses, not horizontally, but with a little bit of slope. And let me show you what I'm trying to discuss here. Let's see, where's my charts here? Yeah, here we go. This is the isentropic analysis page at College of DuPage. And to get there, you're going to just put in weather.cod.edu, go to their analysis page, and you'll have this isentropic maps selection. And it'll look something like this here. So what you're looking at is these 280s, 285s, those are the lower levels. And then as you go up to the right side, these are the upper level isentropic maps. So let's take a look at a couple of them. We're going to go over to the very left, the lowest maps, and see what it shows here. Now these black lines, these are not pressure. These are actually heights of the isentropic surface. I know it's starting to sound a little bit complicated, but we're going to try to keep things a little bit simple here. The important thing is, let's see, you can, yeah, see, these are actually our pressures, but we have to relate these in terms of where the ground is. See, 1050 millibars, that's going to be below the ground. So we're not going to actually use this chart. Let's go up a little higher. Now what we're seeing here is, yeah, these are pressure lines, but what we're talking about here is, see this 950 in Texas? That's the 950 millibar level, and that's going to be up at about 1,000 to 2,000 feet. And as you go up further north, like in Nebraska, see there's 775, 750, 675. Those are going to be in the mid-levels of the atmosphere, up at about 10 to 15,000 feet. Now, some of you may not know how to convert these pressures to height. What you can do is just grab any skew-t. And if you've got like 975, you just bring up a skew-t. If you have 675, it would be like right around here. Some of the charts will give you kind of a readout on the right side showing the height in thousands of feet. But on this particular chart, they've got a kind of a band right here that shows the geopotential height in meters. So that gives you something to go off of. So 675, that would be about 3,000 meters, which is about 10,000 feet or so. So that's how you would do that kind of conversion. It's also good to have like a chart of common conversion values. And I'll just give you a couple. 700 millibars, that would be about 10,000 feet. 500 would be about 18,000. And 300 would be about 30,000 feet. And you should be able to find a conversion chart like that on the internet. That would just give you kind of a ballpark of where these pressure levels are located with respect to height. So you do have to kind of keep that in mind as you work through these charts. That's probably the only thing that's really hard about isentropic analysis. So obviously what we're seeing here, these are heights that are very close to sea level, and here are heights that are in the upper levels. And these are kind of shaped by the air masses that we have present. So this cold air mass that's across the North Rocky region, that cold air mass tends to displace the isentropic height surfaces upward. And that's pretty much a rule of thumb. Where you have cold air masses, the isentropic surfaces are displaced upwards. And I think a good analogy for that is sheets on a bed. And if you have somebody like in bed under the sheets, they kind of represent a cold air mass, and that's going to displace the sheets upwards. What that means is the parcels, the air that's trapped within the sheets, like you see on this region here, if it is heading north, it's going to have to climb to higher heights because it's trapped within those sheets. It's got to go up to where the cold air is, where the sheets are higher up in the atmosphere. So it's going to ascend. And as we know, any kind of ascent is usually associated with clouds and precipitation, particularly where relative humidities are high. And it's convenient that on these charts we have green, which indicates relative humidity. And that's a measure of how close the air is to saturation. And you can see 90s there in New Mexico and 90s in Arizona. So you don't have to ascend very much to get clouds and precip. Okay, so to put this together very quickly, what we see here, the 850 millibar level is about right here. That's about 5,000 feet. I'll put 5. Well, it's kind of hard to draw with the mouse. Okay, then 700, that's going to be about 10,000 feet. And then 600 will be about 15,000 feet. I really need to hook up my graphics tablet. That would work much better there. All right. And then surface is going to be kind of like out in this area. So what you see here, the winds at the 298 Kelvin isentropic layer, they're flowing from south to north. And we're getting all this ascent over the central plains there. And the air is very humid, so it's very likely to saturate and give us cloud material there. So, yeah, southerly winds, we can kind of see that on the skew-ts. I'll bring up Fort Worth there. And you can see, yeah, southwesterly winds there, and Little Rock, southwesterly winds. So it definitely does help to have south to north flow to get clouds forming within a cold air mass. When you tend to have north to south, that's kind of a catafront situation, and you tend to get kind of a more clear setup behind the cold front. So that's why some fronts tend to be cloudy and others tend to be clear. And this is definitely an anafront. If we had a catafront, it would probably be kind of clear back in this region. And as you go up in the mid and upper levels, you would see a lot of northerly flow. I would probably emphasize maybe low and mid levels for that. So we don't have that. We've got more of a south to north flow, and thus all these clouds. All right, so hopefully I haven't lost too many of you. Let me check in and see how things are on chat. I should let you know I've got a new microphone here. I don't know if let me know if it sounds any different. For the past 3 years, we've been using a Rode NT1, and I've switched over to a Blue Yeti. And my impression is the Rodes are better, but there's something about that microphone I didn't like very much, and I think this might be sounding a little bit better. Sue M., welcome to the webcast. Erica Baker, Coffeyville, Kansas, 44 with north winds, up to 26 there. Carl Burkhoff is here. Burl H., Fun with Tech, Willie Greenway in Georgia, Ron Chalfont out there in California, Adam Davis. Got Bill K., 52 there near Atlantic City. Meat Puppet. Megan John reporting 35 in Minnesota, an inch of snow. Okay, Sue M. mentions my voice is sounding lower. Okay, let me just scroll through this very quickly. Yeah, because we're aware of that. We've called it the this is CNN effect. And let me just check and see if that's still going on. Okay. Yeah, let me know if you're still seeing the sound acting weird. And if so, I'll just kind of reset things. Okay. Let me switch over to my control panel here. I'm going to try switching the... and let me know how this... And that might clear up some of the distortion that you're hearing. I'm not too sure what's causing that, but it sounds like we may have to run some tests there to see what's going on. But I think that might have cleared it. If not, then let me know. Anyway, I'm going to try to keep things moving here, but I'm going to check back in. Okay, you guys are still hearing issues? All right, hang on a second. Okay, I restarted the audio engine there. And let's head back, and I'm going to, let's see, where are we at? All right, we've gone over some of the upper air maps. We've gone over some of the surface maps. And let's head into the satellite. And there's what things are looking like this evening. Okay, that fixed it. Okay, it sounded like we had to reset the board there. All right. Good news. Let me get my windows fixed here, and we will continue. So there's how things look this evening. You can see we're looking at infrared imagery. And what's interesting is you can see the air mass contrast. This is infrared imagery, which is sensitive to temperature. So pretty much north of this line here in Texas, you can see kind of brighter grays, like in this area right here, contrasting with the darker colors in this area right here. So that's showing you the temperature gradient in that region. And we'll just zoom in on Texas there. And there it is. So right there, very sharp thermal gradient. That's at around the San Angelo area. And you can see the temperature gradient in that area, 84 at San Angelo, 84 at Brady. And then you go up to the north and you have 50s. And some of that cool infrared is actually being caused by the stratus speck behind the front. Then southwest of Fort Worth, you do see that thunderstorm moving through that area. Another thunderstorm back around south of Pine Bluff, Arkansas. And let's kind of go region by region and see what's going on. Northwest U.S. looking pretty clear. And you can see the colder mountaintops, some of it snow-covered out in this area here, Montana, Idaho, Bitterroot Range all the way down into Wyoming. But overall, not a whole lot going on there. Going to the southwestern U.S., also pretty quiet. And we do see a little bit of reflection of the upper-level disturbance. Remember, we have some troughing out in this area right here, so you can see a slight bit of cyclonic rotation in that region. You can see that kind of in northern Arizona right there. There's kind of a very slight curl to this mid-level cloud right there. Okay, for the northern plains, it looks very cold on the infrared imagery. And we do see an upper-level low up there in North Dakota. So this is associated with a bit of an Alberta clipper coming out of that region, kind of a reinforcing shot of cold air working its way southward. And then down in the central plains, you see the southwesterly flow. There's actually a bit of overrunning going on, and this is the kind of thing that we would be able to pick up on the isentropic maps. So let's do that real quick. Now these clouds, we have to kind of get an idea how high they are. This is going to be probably about 15 to 25,000. This is probably a lot of cirrus. So that might be a little bit, yeah, that's going to be over the top of the frontal layer. So this is all pretty much just jet stream clouds. But let's take a look at it anyway. Go back to the isentropic maps. That's going to be up at about, let's see, 400 to 300 millibars. So we would actually be going all the way to the right out in this area here. Yeah, I might go with that right there, maybe 600 millibars. I guess there could be some mid-level cloud in that. But let's see, we've got very humid conditions in the mid-levels right there. See the 600 millibar. And then there's a very slight trajectory to the left of the height lines. You can see they're kind of like climbing through this area right here. So if I draw the streamlines, see, that's the kind of climbing that I'm referring to. So yeah, there's a little bit of ascent in that area. And even at even in the upper levels right there, this is up at about 18,000 feet. Even a slight bit of ascent in that area too. Check out weather across the northeastern U.S. Head up there, and looks pretty quiet. They're expecting the big system coming in from the west there. You can see earlier today the infrared imagery was a little bit dark in this area here. Michigan, New York, Pennsylvania. Probably some warm conditions in that area. And let's... Yeah, we're checking this area out. Yeah, we've got 50s right now. It's probably up close to 60 earlier today. Maybe in the 60s. And then we go to the southeastern U.S. and looks fairly quiet there. You can see clear skies across much of northern Florida, Georgia, and then up in the Tennessee and Carolinas area, we do pick up some mid-level clouds. And this is likely to be mid-level, maybe 5 to 10,000 feet. Let me just see if that shows up on the infrared or on the isentropic maps. Okay, yeah, that's probably pretty good right there. This is 875. That's going to be about 5,000 feet, and you can see a lot of isentropic ascent, a lot of crossing of the height lines. And let's go up to 294. This is a... hang on a second. Yeah, there we go. Yeah, it's going to be about 5,000 feet, showing lots of ascent. And the other thing that we got to keep in mind is that this is probably this morning's data. Yeah, in fact, it is. So it's a little bit old, but you see 12Z right there. They should be updating that a little later with 0Z data, and that'll give you kind of an updated picture there. So this is a good snapshot of what was going on this morning, but a lot of that weather is still going on even at this time. Okay, let's look at the forecast and see what's going on. Yeah, I'm sitting here wondering about that Darth Vader thing. I wonder what's causing that. I guess there may be some sort of bug in that that mixing board. So anyway, yeah, I appreciate the help sorting that out. I'm going to have to remember to reset that whenever we start a new webcast. Okay, high resolution rapid refresh. This is showing the weather overnight, and that front running right through that area right there, and you can see the Anna front situation. Lots of precip focused back behind the front rather than out ahead of it. And we run the maps overnight. Looks like precip breaking out along that front from central Texas back to northeastern Texas. And that front should just continue pushing southward overnight. And then by morning, it's going to be all the way through Houston and San Antonio. And it looks like a bit of an MCS coming together in the San Antonio area. Kind of a wet start to the day. And let's see what's going to be going on tomorrow. Let's actually look at the upper levels. There's all that troughing out to the west. All right, so going into the upcoming week, you can see a cutoff low shearing out across the southwestern U.S. there. So that split flow pattern is going to be sticking with us for a while. There's the North Stream right there. That's going to continue to bring disturbances into the Great Lakes and Northeast. See that area of coloring right there? That's indicating a jet max coming out of Manitoba, and that jet max is being caused by strong baroclinicity, very strong temperature advection. This is actually a front coming out of that area, kind of an Alberta clipper. So there it is, heading towards the Great Lakes tomorrow. So that's going to bring another blast of cold air to that part of the country. Meanwhile, this southern stream system will bring moisture up into Texas and New Mexico, and that'll probably go up on top of this cold dome out in this area. When you have this kind of southwesterly flow over a cold dome like this, that can be a very potent rain situation in December and January, February. That can produce snow. That's this. In fact, this kind of situation that you see here, this is what we see with a lot of snow events in Texas. Very deep southwesterly flow, troughing out to the west, and a cold polar high across the Great Plains. So running that forward, maybe not snow for Texas, but likely a lot of cold rain. Continued southwesterly flow in Texas through midweek. Meanwhile, up in the Midwest, very strong northwest flow, bringing more cold air southward. Here comes another Alberta clipper on its way in. Surface front with that should look something like this. Kind of a stormy pattern for the Great Lakes there. And out to the west looks like another trough trying to break down this ridge. And let's see if it has any luck. Yeah, you can see the ridge kind of flattening out right there as that trough goes over the top, but that trough is going to emerge on the other side after the weekend. So here we are up to next weekend. Here's the trough about to come down the backside on Sunday, and then it's heading into the Great Lakes right there for Monday. So about a week from now, maybe some more snow showers developing for the Great Lakes region. Well, that trough, or that ridge out in the western U.S. is really anchored itself there. These troughs are trying to break down that ridge, and here comes the next one onto the California coast, Tuesday the 23rd. And yeah, that one makes progress inland, so that should be bringing a frontal system into the western U.S. Still looks stormy for the Texas area. And yeah, negative tilt, or actually that's a positive tilt trough coming down from the northwestern U.S. for the end of next week. So yeah, that's kind of a mouthful there, but looks like a very active pattern through the next couple weeks. So we're definitely not going to be sitting around running stock footage and waiting for winter. It's already up on us. Okay, let me check back in on chat. For you long-timers, let me know how the microphone sounds compared to all the previous shows. Let me know if this is an improvement. And let me go back up into the chat. Okay, Leslie made landfall in Portugal. That from Meat Puppet there. Got Ryan Toomey's here in Dodge Vare. How are pressures determined to create the isobars? Well, we can use barometers at the surface, but the radiosondes that are launched, those have their own barometers. It's a pressure transducer, and it's just reading off pressure, and then we run that through equations to get height from that. So yeah, barometers are still the backbone of observation. Dodge City altimeter setting converted to millibars. Yeah, let me go back to that. Not too sure what we were looking at there. Yeah, all these plots, I got rid of the pressure plots to make things a little more legible. That's one of the things you can do in digital atmosphere. Get my window back here. Yeah, station plots. You can make it altimeter setting, and sometimes I use that. See, there's altimeter setting. Then when we replot that, you can see the pressure at like Lubbock, 30.07 inches. Looks a little more cluttered there, so that's why I don't use that too often. I figure most of you are probably interested mostly in temperature and weather. All right, going through chat, I'm just going to have to kind of go through this quickly. Adam Davis mentioning chasing. Yeah, it definitely does change your viewpoint. Yeah, for me, chasing, I haven't been out in quite a while, but when I chased, it was largely to, you know, see the puzzle coming together. You know, it's like back where you have your data, you know, when you're going through the maps, doing the surface analysis and stuff like that, it's kind of like a big puzzle. And then when you go out where the storm is, you kind of see the realization of your prediction. So it's certainly a lot of fun, and hoping to get back out there one of these days here. Okay, big old cold dome, snow squalls, northeast North Dakota. Andrew Hotchkiss reporting warm conditions. Northwestern Pennsylvania had lots of sun today. Fred Reamer, yeah, reporting those snow squalls. Carl Burkhoff, mixed precip earlier in Wisconsin. Dwayne Ward says the microphone sounds clear and crisp. Picks up background noises. Yeah, that's one issue. That's why you see so much soundproofing in studios. And I've got a lot of soundproofing here, but it's not quite enough. Ryan Toomey's mentioning Nadine fizzled out for now. And Mike Estwick had to use a license plate to scrape ice off the windshield this morning. Okay, I think that's about all I got for today. I appreciate you watching the webcast. Let me get the music going. And I think we're set. At least I think the music is going. Anyway, everybody take care, and we will see you again on Tuesday. Bye-bye.